means that if I tell my supervisor that I am at 90% confidence, it means I'm sure with whatever we have covered. Yeah. If we have covered out of 100, we have covered 90%, then I'm in a confidence range of 90% sure that these students can make it with or without any further lessons. Now, what does that call for? This calls for one, review of the normal distribution curve. Whereby, if you recall, our curve was always looking like this. We are going to have Z alpha over 2. Whereby, if this is the percentage at which we are confident, for example, this is the confidence region. This is no confidence. This is no confidence. Now, this no confidence zone behaves in a way that, if, for example, I've seen this is 95% confident, the 95%, the probability of being confident is actually 95 out of 100, which is 0.95. When you have 0.95, what do you get? When you have 0.95, what do you get? Someone press the calculator. You get 0.475. Eh? Yeah? Hello?
Yes, teacher.
So this side is 0.475. This side will also be 0.475. Now, why these ones are Z alpha over 2, Z alpha over 2? It's because these shaded regions are the same. So in that case, the alpha is going to be 95%. The maximum percentage, which is 100, minus the 95%. So the alpha becomes what? 5%. But because we are halving both cases, then alpha over 2 is going to be 5 over 2%, which is actually 0. Which is 2.5. Eh? Now the probability of getting Z alpha over 2 is going to be 0.0025. Is it? Sorry for the interruption. Now I was illustrating how the Z alpha over 2 comes about, okay? Just for interpretation. So I was trying to show you, this is estimation. And I had showed you that if you have a normal distribution curve, the Z alpha over 2, we had seen that if we had 95% confidence, this side would be 0.475. Also, this one will be 0.475. Then there is this extreme which we have left out. Now, if that is the case, if we say that we are at 95% confidence level, it means you are confident that out of 100 times of the estimate will fall between the upper and the lower values, which has been specified by the interval, which we shall be finding. Now, in this case, I've showed you how the Z alpha can be attained. And I've said alpha comes from 100 minus the percentage you have, which gives you 5%. Then alpha over 2 would be 5 over 2, which is 2.5%. So the probability of alpha over 2, we are seeing that it is going to be 2.5 out of 100. And this is actually 0.025. So this side is 0.025. This side is 0.025. So we shall be using this Z alpha over 2. Now, the definition states that the confidence interval.
Excuse me, sir.
Yes, please.
Where did you get the 95% from? And also 0.475.
Oh, very good. The 95% confidence, it is always given. They will tell you the probability, blah, 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 given that we are at 95% confidence. Yeah? So whenever they give you the 95% confidence, you will know that you have a probability of 0.05 from the mean, from the line of symmetry, from here. I don't know why.
Excuse me.
Yes, please.
I'm requesting teacher to repeat for me. I have not been around.
You've not been around it? So I was saying the confidence interval is defined by this expression, by the mean x bar plus or minus Z alpha over 2 times sigma. This is for a population. Then for a sample, mean you'll have x bar plus or minus Z alpha over 2 times sigma over root of n. This is for a sample. Remember, the variance for a sample is sigma squared over n, whereas the variance for a population is just sigma. So if it's a population, then you get the confidence interval from the mean plus Z alpha over 2 times sigma. If it's a sample, you get the mean from Z alpha over 2 times sigma over root n. Now, these are all not complicated. Do you remember how we got Z values? It is what we are finding for Z alpha. The rest of the things are always given in the question. So you'll have the x bar, you'll have the sigma. Sometimes it is written like this. Sometimes we write it like this. That mu plus or minus Z alpha over 2 times sigma, or mu plus or minus Z alpha over 2 times sigma over root of n. So n of the given cases can be true, okay? Because you're looking for the interval within which the mean can be assumed to be lying within the 95% confidence interval you have, that it is actually true, the mean would lie there. Now, I know people will not enjoy very much about these estimators until I give an example. So with that, allow me to take you straight to an example and we see how we can handle confidence intervals. Those of you who will go ahead and do CPA, you will meet these things again. Economics, business courses, IT, even biomath, those of BCM, you will come back to these concepts, whereby we can be at 95% confidence that all people are vaccinated. We are at 95% confidence that the population of the world cannot be handled again by the corona pandemic. My friend, we are not even at 50. Vaccination in Uganda, we're not even at 30. We are not at even 30% confidence. But those are very low marks. But according to the questions we shall see, the most common percentages are 93, maybe 94, but the most common one 95, 96, 97, 98, 99. Most common questions 95 and 99. Those ones, you even cram them in your head. The Z alphas. And then we are going to use the logbook. We are going to go to page 50. That lower column, which is going to be very relevant in this topic. That is why whoever missed reading those tables, you are in trouble. Here, a calculator may not be of much help. So example 1. So example says a random sample of 120 girls is taken from a normally distributed population of school girls. Comma, have a mean of 16.5 and variance of 18. Determine the 96% confidence interval for the mean age of all school girls. So we can determine in what range these girls fall. Okay, so X bar is our mean, which is 16.5. What else has been given? Sigma, which is sigma is root of 18. The sample is 120. We are at 96% confidence. At 96% confidence, so the probability of confidence is equal to 96 over 100, which gives us half of that probability is 96 divided by 2. What do you get?
.8.
So this is 0.48 because you've divided 0.96. Dividing 0.96 by 40 by 2. 0.96 divided by 2, you get 0.48. So this 0.48, remember I told you if you draw our curve, that is where the probability of 0.48 will lie. So here you'll have Z alpha over 2, Z alpha over 2. This is 0.48. This is 0.48. Beyond that, you have alpha. Now, this is a negative alpha. Of course, the other one is a positive. Now, remember our formula states that, you get x to be equal to, you get the interval from x bar plus or minus z alpha over 2 times sigma over root what? N. Now, we need to find z alpha over 2. We need to ask ourselves, what z value did we read to give us this probability from 0 up to z alpha? So, read z alpha over 2 from the table. What gives you 0.48? Go back to page 50. Logbook. I told you when we begin using a logbook in normal distribution, we shall never throw it until we finish the syllabus of statistics and probability.
Yes.
Hey, but whoever has no logbook, those are your problems. Those who have logbooks, talk to me.
0.48.
What have you read to give you 0.48? You're looking for the Z value. Was this subtopic started last? Habiba, this is new. We have started it today.
It's not shower.
No, the question sometimes.
Excuse me, sir. Even for me, I'm not getting anything.
It is
For
okay.
sure.
It is okay. You relax. You relax. Confidence interval is the easiest from binomial up to where we stopped last week. The only thing I want you to know is that you need to have this expression with this. The expression for confidence interval. Wait, something's wrong with my pen. I don't know what's wrong with it. It takes itself to where I don't want it to. Says win. Now win, what are we winning? Has someone read the Z value? Is that the formula for the population?
Where we
This is
get
the formula
from?
for the sample. Because they said in a random sample. Guys, my pen is freezing. Eh? And I don't want to set up a blackboard, a whiteboard right now. It will take very good time of mine. Now I've seen why it is disturbing. Erase you. And the problem, the device I'm using, none of you knows it. So none of you can help me. What's wrong with this out? Okay. Come on, come on. How many minutes to 11? Setting up a blackboard. I wanted to do so. May take some time. Okay. I was saying it is Z alpha. What Z alpha have you got? 0.498. What do you read? Hello? Guys.
Excuse me, sir. Does the X stand for the mean?
Yeah, the X is here. Like I said, you can be given mu as the mean, or you can be given X bar as the mean. Guys, what I was trying to say, confidence interval is just this formula for this one. What do you look for? Only Z alpha. The rest are always given. Answer. Maybe people will be happy like that. This is the crowning part of normal distribution. So it has begun today, Habiba and Ukashova. Guys, I was saying, go to your table. Do you have the tables?
No.
Then you can't do the
Yes, teacher. Yes.
Whoever has no table, download it now. Or someone share a screenshot of the table in the group for people to be helped. Share both page 50 and 51. Okay? Now, those who have the table. Okay. Let me also go to my table now here. Which page are you on? Yeah?
51.
51. Now 51, look for 0.48 as the probability, not Z. Look for the probability of 0.48, whether it's there.
2.065.
You have read 2 points?
0.65.
2.05.
Very correct. Those who don't know how to read the table, we are back. The return of the table. Now, when we get this, straight away, we go and substitute. The confidence interval will be, substitute will be, what is our mean? 16.5 plus or minus Z alpha over 2, 2.054 times sigma. Sigma we go to what? Sigma is root of 18 divided by root of 120. You get two answers, one positive, one negative. Share the table in the general group, people asking for help. They are not serious students. I always mentioned that the table will stay until we finish the syllabus. But now you are there, you are dangling around. Guys, calculator, what do you get? This term. Hello, stop singing for us. Mute. Someone press the calc, root of 18 divided by root of 120 times 2.054. What answer do we get?
Zero 0.7955.
0.7955. The lower limit is subtraction. So the confidence interval is written in this case, the lower limit, then the upper limit. So the lower limit is the subtraction. The upper limit is the addition. Get me the lower limit. Okay, it's compute. 16.5 minus that answer. What do you get?
15.7045.
15.704. Only for the small places.
45.
Okay. Upper limit 17. 0.2955. Is that true?
Please, you first share for us the page number that look.
Page 50. Yes, Abel. Lucky.
Excuse me, sir.
Yes, please.
Sir, can you please pardon, like, I'm not getting the question. I've been going on and off.
The question was asking us to determine the 96 confidence interval for the mean. You have to be sure that the mean lies within the confidence interval you are getting, and you are at 96% confidence. So if you are at 96% confidence, you find the interval, which interval when you get as the solution, the mean should be able to lie within those two values. Now, according to what we have found 15.7045 and 17.2955. Does the mean lie between those two values? Yes, it does, because it is 16.5. Now, how would you prove that? You prove that using either the formula for the population or the formula for the sample, depending on the question. Now, the question was talking about a random sample, so we have to use equation 2. Now, according to these questions, I told you, I've said confidence interval is one of the easiest parts. The only problem it has is one, to find Z alpha over 2, when people don't know how to read tables. You go back and find that value, which Z alpha over 2 gives you the probability of 0.48. When you get that value, which is this one, everything is given. Substitute answers. So that's how we got the answers. Okay. Okay, let's screenshot that and we have another number. So the lower limit we have got 15 point that, upper limit we have got that. So the 96% confidence level for the mean mu. Sometimes you write it like this, by the way. We can say 15.7045 is less or equal to, the mean mu is less or equal to 17.2955. Never get negative answers here, unless if the mean was given as a negative, but it is so strange. Very strange. Guys, has someone shared a table, a thingy? A what? Because I want to show you another, the shortcut for the table. Someone show me the table. Let me see if we have it here. So as we wait for the table, let's have another number. Now, this one is a little bit interesting. It says a random sample. Random sample of 100 items is taken from a normal population. Had the following. Had the following data. X bar is equal to 82. And summation of x squared is equal to 686800. Find the one unbiased estimate for the population, mean and standard deviation. Now, those of you who don't remember these things, you are finished. 2, 97% confidence interval for the population mean. 3, 98.12% confidence interval for the population mean. Very good example. So there we are. With that, we need to first find the standard deviation. Okay. And we shall also need to find, okay, the mean has been given, so we shall need to find the variance and standard deviation. All right. Now, let us go by that and see what we shall have. So the first thing is A, for the unbiased estimate of mu, the mean is 82. Now we need the unbiased estimate of the sigma. Unbiased estimate of the standard deviation. It is got from what formula? Who recalls? The variance for the unbiased estimate is given by n out of n minus 1 into summation of x squared over n minus x bar squared. You can even check the logbook, those of us with logbooks. So it means the sigma is the square root of the variance, which is n out of n minus 1. So x squared out of n minus the mean x bar squared. So can we substitute? Sigma for the unbiased estimate can be found from the square root. The random sample was 100. So we shall have 100 out of 99 into 686,800 minus 82 squared. But this is over n, which is over 100. Someone compute with a calc and get us the answer.
$12.005.
12.0605. Very good. Now, that is old knowledge. I expected people to know when you just started descriptive probability. I mean, descriptive what? Statistics. The second question says 97% confidence interval. The 97% confidence interval has the following features. 1, Z alpha over 2, which is a negative, and a positive Z alpha over 2, which is beyond. And the probability there is 0.003. No, it is just 0.03. Then 97. When you have the 97, what do you get? They have told you the probability. We are having a 97% confidence. So this probability is 0.97. So when you have that probability, you'll get 0.4. You get 4 remainder 1, 17 goes there, 8, remainder 1, because they are 5. So this is 0.485. This is 0.485. So always you have to have that confidence interval given in terms of probability. Now, what is the Z alpha we have read? Go to the table and check out what value do you read to give 0.485. People have refused to share tables. Okay, someone has shared. Someone has only shared one. Mister, this page you have shared is wrong. Let me first show it to people. Guys, this is the wrong page. Is this your page 50? Let me first check. Guys, someone share a correct page. And where are people reading values from? Someone share a correct page. I want to share with those people who don't know how I'm getting the values. Share page 50 and page 51. Okay? Both of those two pages, I need them. I'm assuming you have advanced level. You have a 4-figure advanced unit logarithmic table. Someone please share. Meanwhile, someone can be giving us the answer. Has someone found what Z value we have read to give us this probability? Because you are reading that value from here up to there. That is why we have
2.1.
2.1. 170. Guys, share your tables so that these people don't complain. You hear people saying as if it's a topic over which we began the other year. So I want to help people so that they are also at par. Also share with me page 50. That table which was having a small table down. Otherwise, if this is a popular sample like they say, then the confidence interval can be got from, the confidence interval CI is going to be got from X bar plus or minus Z alpha over 2 times sigma over root of n, which will give us, the mean was given as 82 plus or minus 2.170 times, open brackets, sigma we got 12.0605 divided by root of 100. Answer, what do we get? I told you this is very easy. Just need to know how to find sigma. Z alpha over 2. The rest will all be good because they are always given.
$79.3829.
Lower one, Yeah?
Yes.
Okay, lower limit 70. 79 point.
0.3829.
The upper limit.
$84.6171.
Like that. So you have to write the interval. The interval would be 79.3829, 84.6171, close brackets. So does 82 lie within those two? Yes, it does. If it does, then you have got the correct interval of confidence and you are at 97% confidence that the mean lies between those two values. So there's a lot of understanding here. So what you're predicting, the confidence you're predicting is that you are sure the mean of 82 lies within 79.3829 and 84.617. And at what percentage are you sure? You are at 97% confidence. Yeah, Habiba,
Excuse me.
are you feeling better, Habiba?
Thank you very much.
Huh?
Yes, thank you.
You're welcome. Someone else was saying something. Do you want me to do the last one?
Sir, I please beg your pardon on Roman 2. My network is stuck.
Roman 2 is
No,
about
so the whole of it.
Roman 2 is all about substituting in the confidence interval formula. The formula says x bar plus or minus z alpha over 2 times sigma over root of n, madam. We only need to look for z alpha over 2. So to get z alpha over 2, you look for the probability, what has given you the probability of 0.485. So you go to the tables. Eh? Has someone sent? Yes. Okay, very good. I've got one table. Send also the other table, page 51. So, madam, you go to this page, for example. The rest of you, can we all see this page? Yes?
Yes, sir.
Okay. If we can all see this page, then this is what is happening. When you come to this page, my pen has been behaving very expensive. When you come to this page, this is easier. You look for 0.48. The other one was 0.48, not so. 0.48. What's wrong? 0.48 is way here. You come and say 0.48, where are you? You are here. What value have we read? 2.05 automatically. The other one was 95% confidence. You remember 95? 95 was 0.475. Eh? Look for 0.475. 0.475 is not there. I showed you the skill. You get the average. You'll get 0.475 in between 0.474 and 0.476. Correspondingly, go and get the average here on the Z values. The answer is 1.96. So whenever they give you 95% confidence, these are very common. The most common one is 95%. Just say Z alpha over 2. Don't waste time. It's now 1.96. Everything else, in most cases, it is given. Then you substitute. This one was 97. 97, was it 97? Wait, 97, when we have teeth, we got what? 0.485. Eh? What have we got? We got that, right? Now, that one, you come also here. It is not, 0.485 is not there, but you have 0.484 and 0.486. So it lies between them. So go and get the average of these two. 2.144 plus 2.197, then divide by 2. What answer do you get?
2.1705.
2.1?
1705.
1705, which is the same answer you got, right? Is that right? Is it the answer we got?
Yes, teacher.
So this table can help you do confidence interval very enjoyfully. If and only if the confidence percentage is a whole number. Huh? Are you hearing my mathematical statement? The confidence percentage is a whole number, like 93% confidence, 95% confidence, 96% confidence, 99% confidence. But if it is 99.9, we go to page 51. If it is like the next one is what? 98.12, the next page you will handle. This one handles obvious percentages with the whole what? With the whole numbers. Then the ones which end with a 5, you get the averages in between where they lie. the average between the two figures where they expect to lie, then you get the Z alpha over 2. So those of us who didn't know how to read the table, have you seen how we read the table on page 50? Any other person with a challenge on page 50 reading? Because this is review, we are just reviewing how to read the table. Because we want to get Z alpha over 2. Okay. Someone please share page 51. Was someone saying something?
Yeah, so what if we're reading figure of four decimal places? How do you read it from this
You go to the other table. That one you can't read it here. Give me an example. Like 0.465?
4906.
4906. You'll find that here 4906 is not there. You see 49, 499, you need 490. 490 is here, you have 491. In between 490 and 491, there is 0.49, 4905. And yet for you want 4906, isn't it? So you'll have to go to the other page. And the other page, if it's also not there, you take values which are very close to it. Are you getting my argument?
Yes, sir, thank you.
So let's get to the other page. Someone please post the other page. Someone please post page 51. Okay, page 51, here it is. The other person over which page was he on, I don't know, but it was so sad that he was on that page. Very good. Now, for those of us who are not in the know of how to read this page, yeah? So here we are, and we would like to read this page. So if we would like to read this page, for example, 0.48, you come here and look for 0.48. 0.48, 48, where are you? There is 4803. 48, we have bypassed it. So this is before 48. Now to get to 48, you have to add on a 2 at the extreme. So look for 2, the immediate 2 is here. This is 0, this is 1, 2, 3. So you should have read 2 point what? 2.0, 0, 1, 2, 3, 4, 5. So 2.5, 2.05. What is this for 0.48? What did we read? 2.0.
2.05.
0.5, 4. Was it like that?
2.054, yes.
Because this is, I think this is 1, 2, 3, 4. So this is a column of 4 corresponding to that. This is a column of 5. And there you are reading 2.0. Now, according to our example here, 0.485, our friends who have been not having tables, look for 0.485 and see whether you can find it. So let's look for 0.485. 0.485, where are you? 0.485, 83, 834, 845, 85. Here you are, lovely. Well placed. So what have you read? You have read 2.1, 0, 1, 2, 3, 4, 5, 6, 7. That is how we came about with that. So that is the only challenge with the confidence interval, reading that Z alpha over 2 from the table. The rest are not so complicated. The rest are always given and you just substitute. My friend who, Ukasha, was it Ukasha? Ukasha, are you there?
Yes, sir.
Are you feeling better somehow? I told you you'll feel better later. Yes?
My confusion is, On 2.17, that last figures 05.
How I got this one of 2.1705, for example.
Yes.
Okay. That is now using the page 50. Okay. Kasha. There you are using page 50.
And the second confusion. When I'm saying that when do you use the page 50 and page 51?
When do you use page 50 and page 51? Very good. I have said page 50 is very confident.
Yes, teacher.
I've said page 50 is very good for use if the confidence is a whole number. For example, they have given you 97% confidence. They have given you 98% confidence. It is always good to come to page what? 50. But if they give you 99.9, 97.6, 95.2, it is safer to go to the other page because this one will not be able to predict those obvious values in probability. Or it is better you stay on only page 51 because page 51 covers all. Covers what you can do here and covers what you can do without this table of page 50. Okay? Ukash,
Yes,
is that
teacher.
better? Okay, now
Yes,
let's go back and finish our number. Let's finish our number. Now, this number says 98 point. The probability is 0.9812. When you have the probability, what shall we get? Someone divide by 2 on a calc. What do we get? When you divide by
0.4906.
0.4906. So this side is 0.4906. This one is 0.4906. I think my friend, the lady, I've forgotten her name. She got this value from here. She had already halved it. Now, we go to page 51 and look for the Z alpha over 2. Okay? So if you go to page 51, let us check it out. here we are. So we look for 0.4906. So 49, where are you? 49, 06, 01, 04, 06, it is obvious, it is here. So we have read 2.3, 0, 1, 2, 3, 4, 5. 2.350 is our Z alpha over 2. Have we all got that?
Yes, sir.
Guys, are we all comfortable?
Yes, teacher.
Yes, teacher.
Okay, thank you for that. So this is 2.35. So to get the confidence interval is got from X bar the mean plus or minus Z alpha over 2 times sigma over root of n for a sample. I wanted to do a number on the population. Let me see if we finish this one, we can do a population. So we shall have 82 plus or minus 2.35 times 12.0605 divided by 10. I think you know now where I'm getting the 10 from, root over 100. Someone get me the answer. So is it any complicated anymore, guys? I told you, I promised you, it's very easy. As long as you know. 2 point? Okay, now get the final answers.
79.1658,
And
84.8340.
definitely 82 lies within that interval. If by luck or by chance, if you ever get a value of 82 or the mean outside that interval, for example, you've got the mean is 65. You are getting an interval 79 up to 84. Stop working, run very fast and check for whatever you're using. Because it is impossible for the confidence interval to be out of the range. I mean, for the mean not to be in that range, or for the mean to be out of that range. Have you got my statement? I told you the confidence interval is predicting that you are at a given percentage of confidence that the mean will lie in that interval. You are sure. I am sure that the average age of you students now is 18. Yeah, girls, you don't want to hear that. But we know you are either 18 or 17, but the 17 are very few. But if you take the average, all of you who are studying now, you're either 18 or 17.5. So if your mean is 17.5, then we should get a confidence interval. And I can say I am at 99.9 confidence that all the new senior 5 entrants are at 17 as their mean age. So this is a very simple concept. Okay. I can't see a population, but I so much want to see a population. Okay, let's do one from the reverse. No 17 here. Or everyone is what? 17 years after staying for 3 years. Hey, you mean I'd even given you less years? I'm sorry, guys. I'm sorry for undermining your age. You guys, you must be like close to 20 now, 18. So your mean age is what, 19? Okay, that's good. You have grown up. Okay, so we can have that down, guys, so that I can have this other number. There's this other number I want us to share. It's interesting in a way that we are working backwards. That's why I want to share it and we do it. Okay, there you go. It has arrived. Like Abe, it's okay to grow up. We don't want to grow up. Habib, leave us alone. Hey, don't overraise it at 16. Please. If the senior 3s are 16, you're joking with the life of it. Senior 3, they are 16. Senior 1, they are 14. One parent was saying, no, I want my girl to go to senior 2. I said, madam, it is impossible. We don't jump in secondary. Guys, there is a very interesting number here. Okay. Just we are back to class. That was an interlude. The height of the mean, the height of men in a particular district follows a normal distribution with a mean sample mu and the variance sigma squared. From a random sample of 100 men, are you hearing the question? It began with a district. Which district would have had a population? But now they have said out of the district, even if they have not mentioned the word sample, random sample, and they just said out of the district, we chose 100 men. It will tell you that these 100 men are predicting a sample. It is observed that at 95% confidence interval. Look at this question, very interesting. The mean mu is within that range. Calculate the value of the sample mean. We are working backwards. Very good question. That's why I wanted to do it. The confidence interval is defined by X bar, we don't know, plus or minus Z alpha over 2 times sigma divided by root n because it's a sample. But according to what we have the lower limit. Remember, the lower limit comes from subtraction. The lower limit is X bar minus Z alpha over 2 times sigma over root of n. We don't know X bar. We don't know. Now, this lower limit is actually 177.5 0.22. Then the upper limit is going to be x bar plus z alpha over 2 times sigma over root of n. And this is actually 179.18. According to our graph, this is what we expect. Z alpha over 2, Z alpha over 2. It was 95% confidence. When you have 95% confidence, it gives you 0.475. 0.475. So we look for the Z value, which gives us 0.475. Mass Ani, let me ask randomly here, who is red day? Who is red day? Aisha Abdallah. What is Z alpha for 95% confidence? Aisha? Aisha, now you're talking Aisha Tari.
Yes, teacher.
Yeah?
Yes, teacher.
Yes, Z alpha for 95% confidence.
Excuse me, teacher.
Yes, please.
Since they've told us mean mu in the question, don't we have to use mu instead of x?
They said mu.
Yes.
Okay, okay. Sorry, we shall use mu. Thank you for that. Aisha, go again to 2 value Z alpha. You have to get in the nyama. Aisha? Aisha, you also. And let me look for another person. Elizabeth Magala, the value of Z alpha for 95% confidence. Faith, are you there? Najat Neisonga. Come on, guys.
1.96.
1.96. Guys, listen to me for the last time. The most common percentage interval of confidence is 95%. You do 1, 2 numbers, you land on 95. 1, 2 numbers, 95. 1 number, 95. So Quram, it is okay. 95% confidence, Z alpha is 1.9 what? 6 period, always. Always, even if you go to Massachusetts, Harvard, Oxford, even if you go to Yale University, everywhere you go in the world, Nigeria University, Weya, South African Pretorian University, you will handle Z alpha over 2 as 1.96 for 95% confidence. Now let me check. Stephen Mugera, are you there? Stephen? Tushime, are you steady? Tushime, are you there? These guys just put on the, and then they go and sleep. Habiba, are you there?
Yes, teacher.
Hey, what's the Z alpha for 95% confidence?
I beg your pardon?
Yeah, Habiba. What is the Z alpha over 2 for 95% confidence?
It's 1.96.
Okay. Nsereko Ukasha. Nsereko. The boys, when you come to questions, they don't appear. Opio Andrew. Opio, are you there, Jalwe?
Yes.
Opio?
Yes, teacher. Yes.
Hey, what is the 95%? What is the Z alpha over 2 for the 95% confidence interval?
It is 1.96.
Okay. If you don't know how to, if you don't know that's 1.96, go to the hustle and find it. Whoever does not know that it is always 1.96 from now on, you go to the table, find it. Okay, now we can substitute. Guys, we are looking for the mu minus Z alpha is 1.96. Sigma was not given. Was it given? No. I think we don't have sigma. Out of root of 100. This is equal to 177.22. You realize mu minus 0.196 sigma is equal to 177.22, equation 1. Then the second one, mu plus 1.96 times sigma over 10. The 10 comes from root of 100, guys. Don't worry so much. It is 179.18. The mu plus 0.196 sigma is equal to 179.18, equation 2. To eliminate, this is the same as this one. Add, you will get 2 mu is equal to 177.22 plus 179.18 divided by 2. A steady student with a calculator, what is the answer?
One 178.2.
178.2. Does it lie within the interval? Say what you want. You're going to put
178.2.
Teacher, you're muted.
So consequently, we substitute and find sigma, which is 0.196 sigma is equal to 179.18 minus 178.2 divided by 0.196 divided by 0.196. I think you now enjoy confidence interval. If you are not, man, I haven't taught you today. And even if you didn't ask any questions, people are asking questions and they are now sounding happy. Yep, someone give me that answer. Let me give you one suicide number. Just so that you also know that the world is not simple. I will come in if it fails.
Teacher, 5.
5, eh? You get such an exact answer. You throw the pen up and even thank your teachers. Then you throw another pen, you thank your parents. You throw another and you thank your colleagues who discussed with you. Okay, guys, with that, I'm happy to announce the end of statistics and probability. If you guys were close, I would have taken you out and we enjoy the day so that we celebrate that if we are now ready candidates to handle any number that comes in statistics and probability. So we are going to have a test on statistics and probability only. From the beginning up to the end. That test is going to be around between 10th and 15th of November. So you have all that time to prepare. But in the meantime, I'm also going to send more numbers on this. I have some UNEP questions and seminar questions with me here. And I'm also going to send those of the population. So be careful, read the statement. Is it talking about a population? Is it talking about a sample? You differ the two, so that when you're handling the number, you know exactly what you're doing. So from next week, we are going to handle pure math. Where is Mr. JB? Integration of what? I'm coming in with curve sketching on Monday, I think. Then Tuesday, I'll come in with conic sections. So that we drive them drastically, so that pure math, you also become happy. By the time you go back, do you know what it means to go back when you are at 95% confidence that you can get D1 in a paper? That is what I want you to go back with, so that you value the time you have spent here. You don't brag, but you know in your head, I'm at 95% confidence that I can sit in a paper, even if they mention in March. Even if they say the January, you name. You are students who have been here, who have caned it up to a maximum. You have caned it to the roof and even ripped off the roof, so you should be at 95% confidence that you can handle a paper of paper 1 by the time we are done. You should handle a paper of paper 2 and get a distinction 1 or 2. That is the confidence I want you to go with. So that is why I'm intending next week. Hey, you already covered? Wait, I've seen Elizabeth saying already covered. Hey, people asking what? Was the next numbers covered? Hey, where have you been? You and you guys, go and check here on the YouTube, whoever missed. If you want special class after reading through the YouTube, get back to me and we see what we can do. But for us, according to our program we have been running, we are class with the statistics and the probability. So we said even you can post the other 2 topics of COG and supermonic. Let us beef up some pure math. So I'm going to handle conic sections, and I'm also going to handle curve sketching. We are handling one on Monday, one on Tuesday. So either you can have different books or you follow them with the same books you've been using. You can see how to handle your notes. But one thing I also want to encourage you people, please endeavor to solve numbers. Don't just enjoy class. When the teacher is done, you have understood, you forget. When you've understood, go and look for every number on a confidence interval and maximize it. There is no number which will come in your name. Even if it's coming from heaven, you will be in position to handle. But if you don't solve and just sit back and relax, numbers will come and you will look like you are not taught in COVID, you are not taught at school. So to avoid such dilemma, once we finish something, look for all numbers in all books, handle them. Then you can nod the head vertically and say, I am done with the confidence interval. I am done with the normal distribution. I am done with the normal approximation to binomial. I am done with binomial distribution. I am done with this, all the topics then you can mention. But if you have not solved enough, we shall always have trouble. So also once more, the book is here, which I want to pick some few numbers, and I said it's called Solve All. It was arranged by me. It has seminar questions, very many of them. Mathematics. There's some few physics behind, but it was mainly for mathematics. Physics, they're just around 10 pages, but the rest of the pages are for mathematics. Very many mock papers, mock past papers, very many mock JEB, Wumuta, whatever, Wachiso, loaded. Me, I'm at 95% that you can sit all these papers here and solve them. You just get your time, say today, every week, I need to do 1 paper. So those who will be interested in the book, you let me know, and I can arrange for you the book. It's 30,000, but please let us keep solving. I trust with the way we are handling ourselves, we shall get the A's. Those who are smiling and enjoying life, when exams are back in next year, for you will be enjoying life for going for where to study, and for them they will be hassling which courses they should go for. Okay, so with that, guys, I'm happy to be part of you, and I'm happy to have taken you through this course that has come to an end. So let us proceed still with pure math, and we see how best we can finalize also that area. That one we might not finish, but we shall push as much as we can, so that by the time you go back, you have value for money. Okay, no further concerns. Have a nice day.